With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is calculate the volume of oxygen required for the complete combustion of 8.8 grams of propane and the atomic masses of each atom is given. So here in this question they are saying that what is the volume of oxygen which will be required when the combustion of propane takes place. So in the combustion of propane, propane is going to react with oxygen to give carbon dioxide and water. So always as a product, carbon dioxide and water is released in the process of combustion. Okay, so this is going to be the reaction. Now let's balance this reaction. So we have 3 carbon atom on the reactant side, so we will have to multiply this with 3. So number of carbon atoms have been balanced. So number of hydrogen are 8 on the reactant side, whereas only 2 on the product side, so we will have to multiply this with 4. Now the number of hydrogen has also been balanced. Number of oxygen in reactant side is 2, whereas number of oxygen in the product side is 3 2s are 6 plus 4, that is 10 oxygen. So we will have to multiply this with 5. Now the reaction is balanced. So this is the balanced equation. Okay. Now in this question they are asking us what is the volume of oxygen required for the complete combustion of 8.8 grams of propane. So they have given us some mass of propane. So let's write it down. So the given mass of propane, that is C3H8, is 8.8 grams. Okay, so that is the given mass of propane. So for calculating the volume of oxygen, we will first calculate the number of moles of propane. So the number of moles can be calculated by this formula, that is given mass upon molar mass. Okay, so given mass, so we will calculate the number of moles of C3H8. okay, so given mass upon molar mass is the formula for the calculation of number of moles. So using this formula, now we have the given mass of propane. So we will have to calculate the molar mass. So for calculating the molar mass, we will just add up all the atomic masses of each atom present in it. So the atomic mass of carbon is 12, so there are 3 carbon atoms, so we will multiply it with 3, plus atomic mass of hydrogen is 1 and there are 8 hydrogen atoms, so we will multiply it with 8. So to get 44 grams per mole, so that is the molar mass of propane. Now we will substitute this in the formula. So the given mass is 8.8 grams and molar mass is 44 grams per mole. So after calculation we will obtain 0.2 moles. Okay, now here as you can see in this reaction that 1 mole of propane is reacting with 5 moles of oxygen, but they are not using the whole 1 mole of propane. They are only using 0.2 moles of propane, and for 0.2 moles of propane they are asking us how many moles of oxygen will be required. So we are taking it as X. Okay, so if we put that in a ratio, so we can say that 1 mole of propane, only 0.2 mole is being used. So in 5 moles of propane, how much oxygen will be used? Okay, so 1 mole requires 5 moles of oxygen. So 1 mole of propane requires 5 moles of oxygen for combustion. Then 0.2 mole will require how many moles of oxygen? So we will just cross multiply it. So if we cross multiply it, 5 will come to this side. 5 into 0.2 divided by 1, which is equal to X. This is the number of moles of oxygens that is required. So that will be equal to 5 into 0.5, that is 1 mole. Okay, so for 0.2 moles of propane, 1 mole of oxygen is required. Now they have asked us the number of, the volume of oxygen that is required. So at S.T.P, that is at standard temperature and pressure, S.T.P, 1 mole is equal to 22.4 liters. So that is the standard. Okay, 22.4 liters. Alright, so that means that if 1 mole is equal to 22.4 liter, then here also the volume of oxygen that will be required will be equal to 22.4 liters. So volume of oxygen will be equal to 22.4 liters. So 22.4 liters of oxygen is required for a reaction with 0.2 moles of methane, or you can say that was given 8.8 grams of propane. So that was the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.